customers complained of duplicate charges. The payment batch job ran twice, processing the same invoices. Two scheduler nodes both thought they were the leader due to a split brain in ZooKeeper. Both picked up the same job from the database. Here's exactly why. But first, let's cover the basics of distributed job scheduling. Welcome to TheCodeForge. Before we dig into that production issue, let's design a distributed job scheduler. A distributed job scheduler is like a team of chefs in a busy kitchen. One chef writes orders on a whiteboard, each cook picks an order, cooks it, and marks it done. If a cook gets sick, another picks up their unfinished orders. The whiteboard is shared state. That's a distributed job scheduler. Cron is great for a single machine, but in a distributed system, you need coordination. Without it, you get duplicate executions, missed executions on node failure, and no visibility into job status. The core problem: multiple nodes must agree on who runs what when. Leader election with leases is the foundation. Each node tries to create a key with a TTL. Only one succeeds. The leader holds the lease and coordinates job assignment. If the leader fails, the lease expires and another node takes over. Here's the leader election code using etc. We grant a lease with a TTL, then try to create the leader key. If it already exists, we become a follower. The leader must keep the lease alive by renewing it periodically. Once you have a leader, it needs to assign jobs to workers. The naive approach is a queue, but if the leader dies, in-flight jobs are lost. Better, workers pull jobs from a shared database using optimistic locking. The leader just marks which jobs are ready. Here's the sequel for claiming a job. We use a version column for optimistic locking and an advisory lock to prevent two workers from claiming the same job. If 0 rows updated, another worker got it. A worker claims a job, starts executing, then dies. The job stays claimed forever. You need a heartbeat mechanism. Each worker periodically updates a heartbeat timestamp. A watchdog scans for jobs where heartbeat is too old and resets them to pending. Workers update heartbeat every 30 seconds. The watchdog runs every minute and resets jobs where heartbeat is older than 90 seconds, 3x interval. This ensures stuck jobs are requeued. Exactly once is a lie in distributed systems. You can only get at most once or at least once. For a job scheduler, at least once is acceptable if jobs are idempotent. Use a unique idempotency key and check it before doing work. Here's the idempotency key pattern using retries setnx. If the key doesn't exist, we set it and process. If it exists, we skip. The key must be deterministic, like a hash of input parameters. The top of the hour. Every job scheduled for 0000 fires simultaneously. Your database melts. This is the thundering herd problem. Solution: add jitter. Randomize the start time of each job within a window. Here's a function that adds jitter to a job's scheduled time. It adds a random offset within the jitter window. Don't forget jitter on retries too. Always use exponential backoff with jitter. You can't debug a distributed scheduler without metrics. Track jobs scheduled versus executed, execution duration, failure rate, leader election count, and heartbeat staleness. Alert on anomalies. Here's how to instrument your scheduler with Prometheus metrics. Use counters for starts, histograms for duration, and a gauge for leader status. Include a unique run ID in every log line for debugging. This is the same issue we highlighted at the start. Here's exactly why that happened. A network partition split the ZooKeeper cluster into two groups. Each group elected its own leader because they couldn't communicate. Both leaders saw the same pending jobs and claimed them. The job ran twice, double charging customers. We switched to etc. with a tighter lease TTL of 5 seconds and added a running flag in the job row with a unique execution UUID. Workers check the flag before starting. This prevents duplicate execution even if split brain occurs. Without advisory locks, two workers can claim the same job if they run the update concurrently. Advisory locks are session level, so if a worker crashes, the lock is released automatically. That's exactly what you want. The incident was caused by a split brain in ZooKeeper. Without quorum enforcement, both groups elected a leader. Always use a coordination service that requires a majority quorum, like etc. with proper configuration. If your lease TTL is shorter than your job's max execution time, the leader loses leadership mid-job. Another node takes over and runs the same job. Set TTL to at least 2x the longest job duration. Don't assume a crashed worker's TCP connection will close immediately. It can take minutes. Always use application-level heartbeats with a timeout. If a job fails and retries immediately without jitter, it hits the same resource at the same time. Always add exponential backoff with jitter to avoid synchronized retries. When using leader election, a stale leader might still write to the database after losing leadership. Use a fencing token, monotonically increasing epoch number, stored in the coordination service. The database rejects writes with an old token. This is critical for exactly once guarantees. The article uses etc. client lease grant and lease keep alive once. In etc. v3.5+, keep alive once is deprecated. Use keep alive with a stream. Also, prev kv, false is not a valid option in the official etc. JavaScript client. Use expect. Key exist, false instead. Always check the client library docs. The article mentions both but doesn't give a rule of thumb. Use PostgreSQL-based scheduling when you already have a Postgres cluster, job volume is under 10K day, and you can tolerate ~1's failure detection. Use etc. ZooKeeper when you need sub-second failover, strong consistency, and can operate a separate cluster. For most startups, Postgres with advisory locks is sufficient and simpler. Here's how to debug common issues. For duplicate runs, check leader election logs and verify lease TTL. For stuck jobs, query for stale claimed jobs and manually reset them. For database spikes, add jitter and increase connection pool. Let's run through some common interview questions. How handle network partition split? Use quorum-based coordination, only majority group elects leader. When use database versus etc., database for 100 workers, minimal ops, etc. for strong consistency. What if worker loses DB connection? Heartbeat stops, watchdog resets job, worker checks version before proceeding. And a few frequently asked questions. Can you guarantee exactly once? No, aim for at least once with idempotent jobs. Difference between scheduler and message queue? Scheduler is time-based, queue is immediate delivery. How prevent false requeue of long jobs? Use per job timeout or extend heartbeat during execution. Key takeaways: leader election with leases is the foundation, but always handle split brain with quorum. Idempotency is not optional, use idempotency keys. Add jitter to start times, retries, and heartbeats. The simplest distributed scheduler that works is better than the perfect one that's too complex to operate. Ready to go deeper? Up next, design Pastebin, then design TikTok, then design Reddit. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.